Hello, everybody at Kima Antalya in Turkey at the International Sports, Culture and Education Conference. My name is Cecilia Yu. I'm an ambassador to United Nations Economics and Social Development Council, as well as a professor in sustainable economics for an independent boutique university called Centurion University, which is a skills-based university in Odisha, India. And we have 3 campuses around the southeast of India that are all built upon skills-based with different projects between India and Australia. So I'm honored to be here. This is actually a backup recording in case anything goes wrong with my arrangements with my travel or anything like that. Sometimes these things can happen as I'm flying in from Scotland. And also I've actually gone via France in order to come home to Scotland. And now I'm going to be with you, hopefully, so that you won't need this recording. But in any case, here we are, and I'm honored to present my work. This is around econometrics of sustainability that is centered around the arts and arts-based aspects of intangible cultural heritage. By way of a background, I want to say that the last time I was in Talia, I gave a speech about intangible cultural heritage and its potential through the digital media in order to convey new and information and also enhance trade and social and economic development, kind of like a Silk Road 3. So since then, intangible cultural heritage has gone a very long way. Of course, since 2003, there's been the research on intangible cultural heritage, but it has very much been focused, excuse me, upon making sure that those that are rare and endangered in the world because of things like loss of biodiversity, climate change creating refugee and different kinds of factors. So this is a research that I've been working on since 2003, when for the first time I actually joined my mentor, who was part of the founding group that initiated the IPCC research into sustainability that won the Nobel Peace Prize in 2007 for sustainability, that was headed by Al Gore. And this is a lifetime of research for me, because at the time, things like United Nations Sustainable Development Goals and different metrics such as that based on more intangible and human development aspects did not factor into the way scientists were measuring carbon and emissions and the different factors with ozones and pollutions. But of course, 25 years on, things have developed a great deal. I'm very proud that my initial research contributed to the ultimate development of Sustainable Development Goals, because what I did was a stochastic regression that estimated the sustainability of businesses based on the environment, including cultural climates that includes intangible cultural heritage. And of course, the UNESCO has formalized many of that, but I want to move here to the reason why I'm here, which is that in about 2 years ago, I partnered with Aim Fournier from MIT, and we've been trying to work on different ways of looking at how we can use the data from UNESCO, which has built up some 4,000 long list of endangered sustainably impacted intangible cultural heritage that will in the long run affect the ultimate survival of everyone on the planet if we do not go and conserve and preserve and also protect some of those intangible cultural heritage that is very much part of the tribes that we all come from, and we all come from a tribe somewhere. So in this way, especially under crisis, war and different factors, many rare and sustainability contributing intangible cultural heritage are infinitely affected by things such as globalization, modernization, and ultimately creating climate refugees and climate crisis. So what we wanted to do was to take a quantitative approach because of the vast number of big data that UNESCO has already collated. And what we began with was the UNESCO chart that used 800 different protected, listed intangible cultural heritage that are arts-based, because of course the sports data is even much bigger than that. However, most sports events are very well funded, so the research on it is much more than this area where it is arts-based, such as fine art, folk art, and also orally transmitted stories that builds images and cultures transmitted from mind to mind from different generations. So with these 800 UNESCO protected intangible cultural heritage, we began to try to look at how we can take a mathematical approach and convert some of the intangibles into things that are much more able to regress into giving us an understanding of what are the initial conditions that will enhance and perhaps reinvigorate this intangible cultural heritage. So AIM will be actually going through the mathematical sides of it, but I wanted to give you all the background because this is a research that is very close to my heart. I've worked with many different examples of intangible cultural heritage, especially as a fine artist that has been at risk. So I guess in this way, we really do need to come together and see that we can learn from the kind of research that comes out of sports and sports science, and how the sports data deal with the metrics and the econometrics of how to enhance intangibles like the ability of one person, one champion, and his or her ability to actually score that winning goal or do an amazing work that consistently win above every other actors and players on the planet, such as at the Olympics. So while fine art does not have this kind of formalized ritual environments, there is a sense that fine art represents the highest aspiration and creativity of a different culture. And it has a lot of values that is actually quite difficult to convert from qualitative into quantitative. However, we are brave. We are trying to, use all of this to enhance the sustainability and the ultimate survival of the planet. Therefore, we are doing our very best to tilt at this very difficult but genuine windmill to try to at least qualitatively and quantitatively find a way to establish what are the initial conditions that will give us the best way to reinvigorate and keep alive the living culture of many visual and fine arts-based intangible cultural heritage around the world.
Well, good afternoon. I'm hoping I'll be there in person, but this recording is a backup, and I won't waste any time. I'll go right to my presentation. This is my part of our presentation about empirically maximally diverse arts-based intangible cultural heritage. I'm a Aimé Fournier from MIT. I'm an applied mathematician and physicist. As I wrote here, I very pleased to have this opportunity to go outside my usual research area because I've always appreciated art and culture very much. This is a picture probably many of you have seen of the ICH constellation. Cecilia showed this to me a while ago, and we had a discussion about her question that she's interested in transmission dynamics between these elements of ICH and under what conditions that transmission is sort of optimal. So we had several conversations, and that led to the following ideas I want to share with you. So the constellation has many nodes. Those are the circles and dots in the constellation. So there are concepts like athletes, many concepts, and their elements. And the concepts and elements and other nodes are connected to each other, as you can see these lines. These connections are semantic, so the constellation is known as a semantic network. So athletes participate in sport, for example, or sports competitions. These are other related concepts. But there are also ICH elements, such as this horse game, which is a kind of sport or sport competition. There can be performers performing the sports, so it's another concept. And there can be other ICH elements in different cultures around the world. So we want to study these elements and how the constellation sort of quantifies their connections. That's the challenge. So I want to talk a little bit about what a semantic network is. So I'm moving a very simple example from the Wikipedia. So we have, again, nodes. So here my 9 nodes go from animal to water, which are objects that I can relate to each other. And the relationships are called the links, and they're called semantic links because there's meaning in that relationship. So a mammal has a vertebra, or a mammal is an animal, and so on, as you can read. Now, mathematicians analyze a network in pretty simple-minded ways at first. So if I have a node n, I can think of the number of connections to the node, and we call that valency. So that's a function, k of n. So you just count the connections, count the links. So for example, the mammal has 5 connections. Now, if I have a very large network, such as the ICH network, we can estimate probability of different values of this valency. And we estimate that using a histogram. So here's an example of a histogram. You can just relate this summary to this picture. There are 1 case of valency 1, 7 cases of valency 2, and 1 case of valency 5, just counting off this picture. Now, here are the assumptions in trying to take this view. Because the elements of cultural heritage are connected to each other, we can assume with some hope that the valency is sort of a proxy for how much transmission is happening. Now, immediately you can object that some of the types of links in the constellation probably don't have to do with transmission, but I think many of them should have to do with transmission. And then the other part of the question is, what are the conditions that optimize? So the different links in the constellation have descriptions. I'll just abstractly say that T is a counting of the different types of connections. I've looked at the data, and there's only a finite number of kinds of connections. So the total valency is a sum of valencies for each type. Again, a very simple idea. I have total connections, and then That's the sum of each kind of connection, each type of connection. So we can do this histogram, which was a one-dimensional example for one variable, but with enough data you can estimate the joint probability mass function for all the different types of connections or valencies. And again, if we have enough data, which I think in the constellation there's 800 something nodes and many possible connections, we can estimate conditional PMFs. Now, if you're interested in diversity, then these probability functions are characterized by their variance, and this approach allows us to quantify what fraction of the diversity is contributed from each condition. And there's a thing called the Sobol method to do that. We can observe in these calculations under what conditions there's a lot of transmission. So that means we'll get pictures and numbers showing what conditions, these little t, lead to how many connections, these kt, and the total transmission, let's say potential of an ICH element. So that's it in a nutshell. Obviously there are many assumptions, and I hope I get to hear your feedback. Thanks for your attention.